All right, welcome back everybody to another episode. Today we're going to be continuing our progress along the quest of implementing every sorting algorithm on Wikipedia in Swift. Now today's episode we're going to be covering insertion sort. As always, these are targeted at beginners and people learning these algorithms probably for the first time or maybe just looking for a brush up on them. But either way, we're assuming that you are a beginner, so there's no need to have a lot of advanced experience here. We do just hope that you've been following along with all of the previous episodes that we've been doing together, because we are going to copy some stuff and we're going to reference some stuff that we've done in the previous episodes. That said, if you haven't done the previous episodes, we've got links to in the channel to how to set up an Xcode project, how to make your first app, and everything like that. So if you need to, go ahead and check those out before we get started. All right, insertion sort. This is the Wikipedia listing for insertion sort. Now in our previous episodes, we've always started with the Wikipedia article, and they've always been pretty good about explaining the algorithm, how it works, and what it does. In my opinion, in this case, the Wikipedia article is not great, so it's going to take a little bit of digging and a little instruction to help you understand what insertion sort actually is and what it does. All right, so let's scroll down here where it actually talks about the algorithm. Now, insertion sort is called insertion sort because it sorts by taking an item in the list, going through and finding where it belongs in the list, and then inserting it into the list. Now, you can see from this little diagram over here on the right where the animation is showing us what it does, where it goes down the list and it takes an item and it finds a place to actually insert it into the list. So now that the animation's starting over here, let's take a look at it. So you can see we have a random list. It starts by leaving the first item in place. The next thing it does is it goes and it looks and it says, okay, 5 is less than 6. Let's insert it before the 6. Then it takes the 3 and it says, okay, 6 is less than 3. It's also less than 5. Let's insert it before the 5. Now the 1, same thing. In this case, we've had a couple numbers in a row that are doing the exact same thing, just inserting at the very beginning. But with the 8, we're actually going to see a difference. 8, it's going to insert it at the end of the list because it's not greater than the last thing in the list. Or not less than, sorry. 7, it is less than 8, but it is greater than 6, so it gets inserted before the 8. The 2, same thing, all the way down to 3, where it'll be inserted as the second item of the list. All right, now that we have a basic understanding of what the algorithm is trying to do, let's jump back over to Xcode. Now we're just going to go ahead and create a blank Xcode Swift playground, same as we've done in our previous episodes. Now, same as our previous episodes, we're going to clear out the hello world and we're going to create a random list of numbers, just like we have for all our previous episodes. This is code copied and pasted directly from bubble sort. Now, similar to the previous episodes, we're going to start with a list that is empty where we're going to put all of our sorted numbers. Now, this is an int array, just like our numbers is an int array up here above. And the same thing we've done in every other episode. So if you remember from the little animation, the first thing that happens in insertion sort is that the first item just gets put in place. So in our case, you would take the first item from the numbers array and assign it to the first number of the sorted array. Now this is because the sorting algorithm doesn't have anything to compare against and nowhere to insert if the list is empty. So now the second pass was actually going through and taking the numbers one at a time and comparing them. So the question is, if I take this second number out of our random numbers list, how do I find out where it's supposed to go in our sorted array? So to clarify what we're going to do here, let's go ahead and throw some comments here to kind of illustrate what these numbers could be. So sorted could start as an empty array, or it always does start as an empty array. And then let's say that it gets 3. Maybe that's the first random number. Well, if the second random number is 5, we want to know, where does 5 compare to 3? Now, obviously, 5 is greater than 3, but if you looked at our algorithm, it was checking and saying, is it less than? So we'll do that. So in our case, is 5 less than 3? Of course it's not, but if it was, then you would say, okay, now we're going to insert the 5 in place of position 0, because that is the item at position 0 is the item that it's less than. Otherwise, we're going to insert it at 1. We're going to put it at the end. Now, if you look and you can see here, 5 is never less than 3, and Xcode is already complaining that 5 is never less than 3. And so obviously the result here is that we would end up with an array that is just 3 and 5. Okay, so let's do that. So we're going to comment this out here, and we're going to go through step by step. Now, we're going to keep the first step of assigning the first random number to be the first number of our sorted list so that we have something to build off of. Now the second step is we're going to grab the second number out of the list, and we're going to say, is this second number less than the item that we already have in our sorted list, that item that we put at index 0? If it is, we're going to insert it before item 0. If it's not, then we're going to insert it after item 0, so at 1. Okay, so now we have one step of our algorithm as well as the starting of our algorithm. We also have a concrete example with our 5 and our 3. Now let's take this, and we want to make it so that we're going through not just the second number, but we're going through every number and comparing it to every item in the sorted list and finding the correct place for it to go. Okay, so let's do a clean slate one more time. We'll just comment this out. What we want is we want to go through every single number in the random numbers list. If you remember the little animation from Wikipedia, you remember that it takes each number from the unsorted part, and it goes and it looks at every number in the sorted part until it finds the place where it goes. So we could just say for number in our random numbers list, and then for sorted number in our sorted numbers list, and compare them, and you would get an if that looks sort of like what we have below. But the problem is when you call insert, you need to know the index where you're inserting. You just can't have the number itself. You have to know where in the list it falls. So instead, we're going to write this loop a little bit differently, but it's going to do the exact same thing. We're going to change this to for index in 0 ... less than sorted.count. So what this will do is this will give us the index from 0 through the end of our sorted list. And then what we can do is we can say, okay, well, sorted list number is sorted sub index. And this is just a different way of writing the same loop where it goes through every single item. But instead now we have an access to the index. So we actually know when it's time to insert where to put this index. So let's do that. Let's go to the if statement. So if our number from our random numbers list is less than the number from our sorted list, then we're going to insert into our sorted list. We're going to take that random number and insert it at the index right before this number that we found that it's less than. So this is just a way of going through every item in the list and finding the thing that it's less than and then inserting it right before it. Now if you look at the code below, this is actually pretty close to finished. We have our if statement that checks to see if the numbers are less than each other. We have two loops, one to go through the random numbers and one to go through all the sorted numbers. So we're actually pretty close. Now there's one other thing here that we need to change. Because we're looping now, we're going to introduce what's called a break. Now what break does is it makes it so that once we found what we're looking for, it exits out the loop. So this loop right here would get canceled early once we found the place to insert it. Because the thing is, we don't want to insert this number more than once. And honestly, once we found what we're looking for, it saves us time to just stop what we're doing and get on with the next number in our random numbers list. So in this case, what we now have is if our sorted list number is greater than our random number, then we go ahead and insert because it's now in order. And then we break, we exit out of this loop. Now, there's a problem here that we need to cover. It's actually two problems sort of compounded into one. One is that below you can see we actually started with something in our list. And in this particular example, the way that we loop through every item, we don't handle the case, what if the number goes at the end of the list? So what if we go through the entire sorted list and we never actually find a place for it to go? Now these are the same problem, they're just manifested differently. One is that the array is empty, so there's nothing to look at. The other is that it's bigger than everything in the array, so after we've looked at everything, we never find a place to insert it. So what we're going to do is we're going to keep track of the size or the number of items in our sorted list. And if we never change the size or the number of items in it, then we know that we never inserted anything. And that could either be because the list was empty, so there was nothing to count through, or it could be that we compared against everything and we never found anything that our random number was less than. Either way, this solves the same problem. All right, so if we get to the end of this for loop and the sorted count equals our sorted list current number of items, the sorted list.count, then we know nothing has changed. And so instead of inserting, what we're going to do is we're going to append. Append is just the same thing as inserting, but at the end. So we will do append the number to the end of the list. So that will handle both of our problem cases. All right, and now that we are finished with our sorting algorithm, we're going to go ahead and print our random numbers and our sorted numbers just to show the results of our work here. So if we come down here and hit play to run, you can see we get printed out a random list of numbers and our sorted list of numbers. Obviously both containing the same numbers, just sorted in the correct order. Now, here's where we hit the extra credit. We've done extra credit in other episodes, but in this case, this extra credit is a cleaner solution. It doesn't require an extra if check, which is kind of nice, but it's going to introduce a new sort of pattern that if you're brand new to computer science or programming, you're not familiar with. And that's with looping through indexes. Now we've already talked about this. We've got for index in 0. We've already done that, right? But what we want is a way of having nested indexes. So we have these two loops inside of each other. They're nested inside of each other. We want to keep track of two different indexes so that we can work and operate on the same array. So this is the thing that, is kind of common in computer science, but maybe you haven't seen before. But it is this naming convention for indexes. So when you have loops that are nested inside of each other, the outside loop, you'll say, oh, well, it's keeping track of index I, which I makes sense, right? That's the first letter in index. But then what you'll do is say, oh, well, for the inner loop, it's keeping track of index J, which is just a different index, but it's sort of known when you're looking at code that I and J are indexes into an array of some kind. And then if you had even more nested loops inside that, it would go to K, and then hopefully you never see anything that goes all the way to L. But you just keep nesting and nesting and nesting these loops. You just keep picking the next highest number. And it's just a convention. There's nothing magical about it. It's just a way people traditionally do it. Okay, so how do we actually use this var I equals 1? Now we're starting with 1 for our index because the first number is sort of special, and you'll see why in a second. But what we're going to do is we're going to say while I is less than numbers.count. So we're going to go through every single index in numbers.count, and then we're going to set up our second one, and we're going to say, well, var j equal to I, because we're going to start at 1 and we want j to also start at 1. So we've got these two indexes, and that's all I was trying to say when we have this sort of convention. Is it's harder to read because they're just named I and j, but it's just important to know that, hey, this is a pattern. Okay, so in this loop, to make this while loop work, we're going to end it with I plus equals 1. So this will happen is every time through this loop, it will march I forward by 1 space. So now for our inner loop. Now our inner loop, what we're going to do is we're actually going to march backwards, if that makes sense. So if you remember the animation was going 1 item at a time, marching forward through the list. but it was marching backwards through the list, comparing them. So in this case, for our inner loop here, I and j are equal to each other, and we definitely don't want j to march past 0 because arrays don't go lower than 0. But what we're also looking for here is we want to keep looping, we want to keep marching backwards while the numbers are less than each other. So how we would say that is, while the random number at j is less than the random number at j minus 1, we want to swap their positions. So that's just a way of you didn't actually see that in the animation, but that's just a way of marching it, the number itself up the list until it eventually finds the place where it's going to land. So how this is going to work is we start at 1, j is equal to 1, and so what we're going to very first pass through here is compare the item at 1 and the item at 1 minus 1, which is 0. So we're comparing the first and second item. And if the first and second item are out of order, then we're going to swap them. So then we're going to do the same thing here that we did with I, except for in reverse, because j is marching backwards. We're going to do j minus equals 1. Now the crazy thing is, that's the whole thing. We have I, which is marching forward through the list, picking a number. And then once we pick a number, j marches backwards through the list, swapping them until the number is in place. That's it. So if we go ahead and add a print statement here, you can see that we have our unsorted list at the top. We have our new sorted list that we created up here and printed out up here that is now in order. And then our final print statement is the original random numbers list now being sorted directly in place. No need for a duplicate list to keep track of our sorted numbers. So hopefully you can see, this sort of extra credit portion I think is worth it because it sorts numbers in place. It looks cleaner. There's no extra if statements. It's just the only problem is it's a little harder to read. It's a little harder to understand maybe if you're new to computer programming, and maybe since the variables don't have any names, it's a little harder to actually sit down and understand what the algorithm is doing. So that's insertion sort. We've gone through a sort of slower step-by-step and more elaborated version of it. And we've got our more abbreviated, but maybe a little bit harder to read version, both of which are valuable, both of which are implementations of insertion sort. They're a little bit different if we're really going to dig into complexity in size, but for these beginner lessons, we're not going to really worry about that. All right, hopefully you guys enjoyed this one. If you do, please like and subscribe. It seriously helps the channel and the videos to grow and to get exposed to more people. And we will catch you on the next one where we will be continuing our quest to implement every single sorting algorithm in Swift. Thanks. See ya.